Okay, Bismillah ar-Rahman ar-Rahim. We'll continue doing problems. We did this one, all the exams problems. Yeah, this one I think we did just recently. -1 to 4. I think we did something similar. Yeah, no need to waste time doing it again. Where is it? It should be here somewhere. Yeah, it's this one. And instead we have 3 here, which will not make a difference. So just it will be over 3, 6 over 3. Yeah. It will be the same thing. So what we have, this is 1 over 3 integral of this. And I know this goes to 6, like in that problem. So this goes to 6 over 3, which is 2. Okay. Yeah, convergence. No need to waste time. Do it again. Okay. This one. Yeah, also I think also we did this one. I just saw it. Yeah, it's this one. Exactly. E to infinity 1 over x ln x all squared. It goes to 1. This one is equal to 1. No need to do it again. Okay, now let me go to this one. So what we have, the same thing. What's my problem? 0, but 0 is not in the part of the domain, so we don't care about that. We care only about the infinity. So t goes to infinity, 2 to t, 1 over x squared is minus 1 over x dx. Okay, dx. No, this integral actually is easy one, but let me do it. It's not that difficult. If I let u equal minus 1 over x, then du is 1 over x squared dx. So this is actually already du. So you have au du, which is eu plus c, which is e minus 1 over x plus c. So this one will be limit. E goes to infinity of what? E minus 1 over x from 2 to t. That will be limit. E goes to infinity. E minus 1 over t. Yeah. Minus e is minus half. Take the limit. I know if t goes to infinity, then minus 1 over t will go to 0. So e minus 1 over t goes to 1. So that will be 1 minus what? This is 1 over e to the power half, or it's 1 over square root of e. That will be the answer. Converges and its value is this. This improper integral. Okay. So what I have, my concern is about infinity here, 0 and 1, which is I'm starting from 4, so no need to think about that. So I have what limit t goes to infinity 4 to t. This is like make it 1 over x minus 1 dx. So let me think about this integral. X times x minus 1 dx. Yeah, this is partial fraction. Very clear, it's partial fraction. Easy one. So I cover the 0, cover the x, so I apply 0, that will be minus 1. I cover this, apply 1, check, it will be minus x plus 1 plus x, which is 1. Okay, so I have minus 1 over then an absolute value of x plus ln x minus 1, and that will be ln plus c. That will be ln x minus 1 over x plus c. So that will be limit t goes to infinity of what? of len absolute value x minus 1 over x from where to where? From 4 to t. That will be limit t goes to infinity of what? Len t minus 1 over t minus len what? 3 over 4. This limit, I can do it easily. Limit t goes to infinity len t minus 1 over t. Len absolute value are continuous functions. So I take len absolute value limit t goes to infinity t minus 1 over t, same degree, that will be 1. So it will be len 1, which is 0. So this is 0. So you have 0 minus len 3 over 4. Can take minus as a power. That will be len 4 over 3. And this is the answer. Yeah, this is almost the same as this one, but it's from 3 to infinity. So this one will be limit t goes to infinity. Let me go to this step, because before it will be the same as len absolute value x minus 1 over x from 3 to t. That will be limit t goes to infinity len t minus 1 over t minus len 2 over 3. This is 0. So it will be 0 minus len 2 over 3, which is len 3 over 2. That will be the answer. This one, yeah, my concern only with minus infinity. So this will be limit t goes to minus infinity, t to 0. Yeah, I'll write this as 2x cubed. Okay, let me do this integration here. So I need to multiply by minus 2 and minus half outside. Yeah, because if I let u equal minus x to the power 4, du will be minus 4x cubed dx. So this will be my du. So I have what? Minus half integral eu du. So it's e minus half u c. So it's minus half e is minus x to the power 4 plus c. So that will be limit t goes to minus infinity of what? Of minus half e to the power minus x to the power 4 from t to 0. Okay, so now substitute. I have limit t goes to minus infinity 0. I have minus half e to the power 0 will be 1, minus that will be plus e to the power minus t to the power 4. Yeah, be careful with this one now. If t goes to minus infinity, what will happen to t to the power 4? It will go to infinity. So minus t to the power 4 goes to minus infinity. So e to the power minus t to the power 4, it will be e to the power minus infinity, and that what? 0. So I have minus half plus 0, which is minus half. So this is my answer. Okay. X squared minus 2x. What is that? No, this is x squared minus x. Okay. Yeah. This one is what? 0 to 1. X minus 2. So my concern is only about the 0. So this is a limit. T goes to 0. I have infinite discontinuity at 0. Infinite discontinuity at x equals 0. before I had infinity always. No. Okay. It goes to 0, t to 1. This is dx over x minus 2. So what I will do, I'll do this integration. Now, what is that? That will be a over x plus b over x minus 2 dx. What is a? Cover the x. 0, that will be minus half. 2, that will be half. That will be correct. So it's minus half then absolute value of x plus half then x minus 2 plus c. So that will be half then x over x minus 2. Yeah, this is the positive part over x plus c. Yeah, so I have what limit t goes to 0 from right of what? Of half then I can make it 1 minus 2 over x. Yeah, from where to where? From t to 1. That will be what? Substitute the 1. Substitute the 1, it will be 1 minus 2 minus 1, absolute value 1, then 1, 0. So it will be minus half, then 1 minus 2 over x. T. Okay. Now be careful. Don't forget the limit of this. Now let me do it in steps. Yeah. T goes to 0 from right. Minus 2 over t. 1 over t. Goes to plus infinity. So minus 2 over t goes to minus infinity. 1 minus 2 over t goes to minus infinity. Absolute value 1 minus 2 over t. That will go to infinity. Len of this also goes to infinity. So I have minus half times infinity, which is minus infinity. So it diverges to minus. Yeah. This one, let me check. My problem is with the 0. Yeah, I have infinite discontinuity at x equal 0. So I split this into 2 integrals. So let me take this one, minus 2 to 0. I want to check this integral. That will be what? Yeah, limit, my problem with the 0. Limit x t goes to 0 from right, minus 2 to t. X is minus 4 dx. That will be what? Limit as t goes to 0 from right, minus 1 over 3, x to the power minus 3, from minus 2 to t. Substitute, you have limit t goes to 0 from right. This is what? Minus 1 over 3 t cubed. Minus 1 over 3 minus 2 cubed. Oops. Minus 2 cubed. Okay. Yeah, if 0 t goes to 0, then 1 over t cubed goes to infinity. T goes to 0 from right. So I have here minus infinity. Is it just a number? Minus what? 1/24. Yeah, that will be minus infinity. So diverges. Diverges. Okay. I think this one we did before. 1 to infinity. Yeah. E to the power minus the square root of x. No. Yeah, it's this one. And the answer is 2/e. 2/e is this one. So let me go to that. Yeah, it is the same. No need to waste time. Again, this is when okay, 2/e. This one sine square. What to do with this? 0 to infinity. It's 0 to infinity. This is infinity. So my concern is about infinity. Limit t goes to infinity. Integral 0 to t sine square x dx. What to find this integral? Okay. Sine square x dx. Okay. I think this one I can write it as what? Half minus half cosine 2x dx. Sine square is this. So that, and by the way, this is positive, should be positive, because it's sine square positive. Okay. So that will be, yeah, that will be what? Half x minus half minus 1/4 sine 2x plus c. So that will be limit t goes to infinity of what? Half x minus 1/4 sine 2x from 0 to t. Now apply the limit. That will be limit t goes to infinity half t minus 1/4 sine 2t minus 0, 0, so no need for this. So now this integral is what? Yeah. This is goes to infinity. Infinity minus. Yeah. This one is just a value. Bounded value between. Actually, it will not converge. But at the end, they have sine 2t is between -1 and 1. So 1/4 sine 2t is between -1/4 and 4. So this is, yeah, it will be a value between -1/4 and 1/4. It will not convert to a specific value, but at the end, this expression or this expression cannot exceed. It will be between -1/4 and 1/4. So that will be infinity for sure. Infinity minus a number, it will be infinity. So this is diverges to infinity. Now let me do this one. This one is what? Integral of x squared. Yeah. How to do that? I want to change this integral into this integral. Strange. Okay. Yeah, this is will be limit t goes to infinity 0 to t x square e minus x squared dx. How to go from this to this? Think about the integration. Yeah, I can do this trick. This is x times x e minus x squared dx. And I will make another trick where I will make this minus 2 and I have minus half outside. So now I'll do by parts, where this is my du and this is my u. So I let u equal x and dv is minus 2x e minus x squared dx. Where I have this is e to the power v dv du, what do you call it? So my v is what? E is minus x squared. Differentiate this, you will get this. Okay, and my du is dx. So now I can change this integral into something with e is minus x squared. So this is the trick. So this will be minus half. What is this? X e minus x squared minus integral of what? Of e minus x squared dx. So this one can be written as limit t goes to infinity of what? Of minus half x e minus x squared plus half integral 0 to t e minus x squared dx. This is the limit. E goes to infinity. It will be infinity times 0. So I need to do it by L'Hopital's rule. I have limit t goes to infinity. T is minus t square. That will be limit. How to do this? Yeah, it will be limit t goes to infinity t over et square. That will be infinity over infinity. So I can apply L'Hopital's rule now. T goes to infinity 1 over 2t et square, and that will be 0. 1 over infinity, which is 0. So this will be 0 plus half limit t goes to infinity 0 to t e minus x squared dx, and that is what? Half 0 to infinity, which is the definition we started with. So this one, the integration by parts plus the definition of the improper integrals. Yeah. Okay, let me do more problems. Let's see what will happen. This is e to the power 3x. I think this is an easy one. My problem is with the minus infinity. That will be limit t goes to minus infinity of what? T goes to 0, e3x dx. That is an easy integral. That will be 1 over 3 e3x from t to 0. That will be limit t goes to minus infinity 1 over 3 minus 1 over 3 e3t. T goes to minus infinity. So e to the power 3t goes to 0. So it's 1 over 3 minus 0, which is 3. Compare just 1 over 3. Easy one. This one, 1 over x, square root of x squared minus 9. How to do this one? I have problem with the 3. Sure. I have infinite discontinuity at 3. Infinite discontinuity at x equals 3. Yeah. So I let x equal 3 secant theta. The x will be what? 3 secant tan theta d theta. Let me see what will happen. First, I need to do the limit. Limit t goes to 3 from right. Not 3 from right. Yeah, I have 2 problems. I have this and this. Yeah. So first, yeah, I need to be careful here. This is, I need to split it into 2 parts. I choose any value. Choose 4, 5. It's up to you. Yeah. Then I need to do these 2 integrals. Let me do the integral in general. See what I'm getting. I can use this now. Yeah, that would be what? 3 secant theta tan theta d theta over what? x3 secant. This is what? 3 tan theta. 3 tan theta. So my answer is 1 over 3. D theta, which is 1 over 3 theta. That will be 1 over 3 secant inverse x over 3 plus c. Yeah. So let me do the first one. 3 to 4 dx over x square root x squared minus 9. That will be 1 over 3. Yeah, that will be limit t goes 3 from right, because I have problem with the 3. Integral t to 4 dx over x square root x squared minus 9. And this integral, yeah, I need to squeeze it because I need the space. 1 over 3 secant inverse x over 3 from t to 4. Yeah, and that is equal to limit t goes to 3 from right of what? 1 over 3 secant inverse 4 over 3 minus 1 over 3 secant inverse t over 3. Okay. Now let me do the calculation. T goes to 3, so I have 1 over 3 secant inverse 4 over 3. Oh no, what is that? Leave it. Minus 1 over 3 secant inverse of 1. What is secant inverse of 1? Yeah. When secant inverse will be 1. That's when theta equals 0. So this is minus 3 times 0. So I have 1 over 3 secant inverse 4 over 3. This is the first one. Now let me do the second one. Integral 4 to infinity. Same thing. But now my problem is with the infinity. 4 to t. Okay. And that is equal to what? That will be limit t goes to infinity of what? Of t goes to infinity of this integration, which is 1/3 secant inverse x/3 from 4 to t, and that will be limit t goes to infinity in this case, 1/3 secant inverse t/3 minus 1/3 secant inverse 4/3. Now, when secant goes to plus infinity, it will be secant pi/2. Secant, if x goes to pi/2, then cosine when secant will go to positive, then cosine pi/2 is 0. Cosine pi/2 is 0. So because of that, secant will go to plus infinity or to infinity, let me say. So this one will be, this one give me what? pi/2. So I have 1/3 times pi/2 minus this strange numbers. So this one will be what? The first one is this value. Strange value. The second one, pi/6 minus the same value. So this is cancelled. So I'm getting pi/6. And this is the answer. Okay. Let me do more. Which ones? Okay. This one is not difficult. Okay. Yeah, my concern is about infinity. So this is the limit. T goes to infinity. 1 to t, 1 minus x is minus x dx. I need to do this integral where I need by parts. Actual tabular will do it. So I have 1 minus x, e minus x, be careful, minus 1, 0, minus e is minus x, plus minus, that give me what? X minus, 1 minus x, same, 1 minus x, e is minus x, yeah, minus e is minus x. So that give me, let's see, yeah, that give me minus x, e is minus x. Yeah, it will be e is minus x minus e is minus 10. Can check, differentiate, you get what? Minus e is minus x. That would be. Yeah, that will be, sorry. There is a minus sign. There is a minus sign here. That will be x minus 1, e is minus x, minus e is minus x, plus c. Yeah. Is it? Yeah, minus. No, that would be plus, sorry. Because it's minus times minus. So that would be plus. So that give me x, e is minus x plus c. Check now. It will be e is minus x is minus x, which is correct now. So that will be limit t goes to infinity of x is minus x from 1 to t. That give me limit t goes to infinity of what t is minus t minus, substitute 1, that will be 1/e. Now I need this limit. I need L'Hopital's to do that because it will be what? infinity times 0, make it t over e to the power t. That give me what? Infinity over infinity now. Use Repeater's rule. I think 1 over e to the power t, which is 0. So this will be 0 minus 1 over e, which is minus 1 over e. And that will be the answer. And this one, it's about secant. Yeah. There's a little bit of calculation here. Okay, let me do the. My concern is about 3. So I have this is the limit. T goes to 3 from the right of t to 5 dx over this. And now let me do this integral. So if I let x3 secant theta, dx will be 3 secant tan theta d theta. So this integral will be 3 secant theta tan theta d theta over, this is 3 tan theta. So that would be secant theta d theta, which is what? Which is ln secant theta plus tan theta plus c, which is ln what? And this is the triangle. Secant is what? Hypotenuse over adjacent. Okay. Yeah, this is will be square root x squared minus 9. And its secant, so that will be ln x over 3. And tan is what? Square root x squared minus 9 over 3 plus c. Okay, so that will be limit t goes to 3 from right. Of what? Of this expression, and then x from t to 5. That will be limit t goes to 3 from right of what? Ln. This is 5. 25 minus 9, that's 16, so it's 5 plus 4 over 3 minus ln. This is what? T as square root t squared minus 9 over 3. Where t goes to 3, that will be what? This is 0. This is 3 over 3, 1. So all of this goes to 0. So I have ln 9 over 3. That will be ln 3 minus 0, which is ln 3. That will be the answer. This one I think we did before. Yeah, no need to do it again. Actually, it's an example in the book. Yeah, I think at the beginning we did it. Where is it? And the first group, yeah, is this one. And my answer was pi over 4. That will be my answer. My answer, where is it? No, it's pi over 2, sorry. That will be my answer. Pi over 2. Yeah. So no need to waste time, do it again. We did it in the first, so it's pi over 2. It's an example in the book, by the way. This one, then I will stop this video. Now my concern is about the 1. Yeah, so I need to split this. I have infinite discontinuity at x equal 1. So I split this 0 to 1 plus 1 to 2. Let me do 0 to 1. That will be what? My concern is about the 1. So I'll make it limit t goes 1 from left dx over x minus 1 square. Let me do this integration. No need. That I can do it quickly. Limit t goes to 1 from left, minus 1 over x minus 1 from, this is from 0 to t, from 0 to t. So I have limit t goes to 1 from left. This is minus 1 over t minus 1. Substitute the 0, it will be minus 1. Now substitute, you have what? Yeah. T goes to 1 from left. So what will happen? 1 over t minus 1. Then multiply by minus. Yeah, I can check it easily. This is 1 over t minus 1. T goes to 1 with the 1. Huh? It will be, it will do this, but with x equal 1. This t goes to 1 from left, so I'm going to minus infinity. T goes to 1 from left, yeah. So it's minus infinity. Minus 1, that will be minus infinity. So it diverges at the end. Who cares? So if this is diverges, then that implies all of this integral will be diverges. No need to check the other one. So the answer is diverges. Yeah, I think I will stop the recording. I think we have a good number of questions. Thank you.